Next, we'll revisit the concept of calculating probabilities, but now with the normal distribution. Below we have a standard normal distribution, meaning our mean is 0 and standard deviation is 1. And we want to talk about what these different statements mean with regards to the normal distribution and how we calculate those results. In part A, we have the probability that x is less than or equal to -1. To represent that probability on our distribution, what we do is find x is equal to -1, and since our inequality is less than, we're going to shade the entire region to the left of x equals -1. When we calculate the probability in part A, what we're doing is finding that area under the curve and to the left of -1. To do that, we'll type in normal DIST, short for distribution. We'll enter the mean and standard deviation for our distribution. In this case, that's 0 and 1. If we hit the magnifying glass, that will just give us a zoomed in, a more appropriate view. And then we can click the box to find the cumulative probability. In this case, we want the maximum value to be -1. We see a picture that matches our expectations, and we get that corresponding probability of 0.1587. Similarly, if we consider the probability that x is greater than 0, greater than or equal to 0, we'll find x equals 0 as our boundary line, and then shade, in this case, everything above that line, all x values greater than that line. And that area will represent our probability. We haven't updated the mean and standard deviation of our distribution, so the only thing that we need to change is that our minimum should be 0, and we get a probability of 0.5, which makes sense because what we're considering is half of the distribution. In the first two cases, our probability was only bounded on one end, but we can also find shaded regions that are bounded between two different values. So in part C, we want the probability that x is between -1.5 and 0.5. Similar idea, we'll use those as our boundaries, and then we'll find the area of the shaded region between those two ends. Meaning now we'll put in both a minimum and a maximum value for a probability of 0.624. Or if we round that to 4 decimal places, about 0.6247. We can do the same thing in example 2. All that's changing is that now we're dealing with a distribution that has a mean of 100 and a standard deviation of 50. But calculating our probabilities will follow the same pattern. We'll update our normal distribution for these new values. To find the probability that x is less than 140, we'll enter in a maximum of 140, and we can click that magnifying glass to see a better picture. We're finding the area under the curve below 140, and we get a probability of 0.7881. In part B, we're asked to find the probability that x is greater than or equal to 160. So we'll delete that maximum value and enter in a minimum value of 160 to get a probability of 0.1151. And in part C, we want the probability that x is between 60 and 80. So we'll enter 60 as that minimum, 80 as the maximum to get 0.1327. And I just realized as I was working through those problems that I put the wrong graph on here. What I created here was a normal distribution with a mean of 100 and a standard deviation of 25, which is not what we were calculating in the problem. But what I would encourage you to do as you're thinking about these probabilities, always sketch out that curve and what that picture should look like so that the picture in Desmos matches your expectations. So in this case, we have a mean of 100. If I want the probability that x is between 60 and 80, both of those values should be less than my mean. So if I end up with a graph in Desmos that doesn't match that picture, then I've done something wrong in creating this problem, or creating my answer to this problem.